Okay, for what we have in section 8.1, problem number 1, it says to use substitution to solve the following system. And we're looking at the same values of x and y that will belong to both equations. And we have the x equal to 3y plus 7, and also negative 3x plus 2y is equal to negative 7. And for what we have with substitution, what we can do is that from the first equation we have x expressed in terms of y, and we can take 3y plus 7 in place of x in the next equation and go ahead and solve for y. So I have x equal to 3y plus 7. And I can just fill in for x. And we're going to have negative 3 times the quantity of 3y plus 7 plus 2y is equal to negative 7. And we have a distribution. Okay, we have negative 9y minus 21 plus 2y is equal to negative 7. And upon combining like terms together, so you have negative 7y minus 21 is equal to negative 7. And joining 21 with negative 7, adding 21 to both sides, so I have negative 7y is equal to 14. And from what I have here, upon division by negative 7, okay, we had that y is equal to negative 2. And going ahead and plugging back in for x, okay, so we have x is equal to 3y plus 7. And with y at negative 2, we have 3 times negative 2 plus 7. 3 times negative 2 is negative 6 plus 7. And negative 6 plus 7 is equal to 1. And upon checking out, okay, so you have x at 1. And we have y at negative 2. And upon checking, and the result is correct. Now, for what we have in the case of number 2, okay, again, we have another substitution situation. Here we have 3x plus 4y is equal to negative 6, and we had that y is equal to 2x minus 7. So I can plug in 2x minus 7 for y in the first equation, and we can go ahead and solve for x this time around. Okay, so we have 3x, and we have plus 4 times the quantity of 2x minus 7 is equal to negative 6. And here we have 3x plus, and 4 over 2x minus 7, we have 8x minus 28. Here we have 3x plus 8x, that will make 11x minus 28 is equal to negative 6. And upon adding 28 to both sides, so I have 11x is equal to 22. And we have with division by 11, x is equal to 2. And taking what we have in x and solving for y. So with y at 2x minus 7 and with x at 2, I can say that y is equal to 2 times 2 minus 7. 2 times 2 is 4. And 4 minus 7 is equal to negative 3. Okay, so we have x at 2. And we have y at negative 3. And checking out. And the result is correct. Now, for what we have in the case of number 3, okay, it says to solve the following system of equations. Here we have 4x plus 5y is equal to negative 4. And we have 4x plus 3y is equal to 12. And instead of substitution, I can use the method of addition, which can involve adding or subtracting equations. And for what I have here, we have identical x terms with 4x. And what I'll do here is that I'll cancel out the x terms in the system and go ahead and solve for y. And let's say that if I subtract the second equation from the first, what I'm going to have here, you got 4x minus 4x, this will go out. And we have 5y minus 3y, so this will become 2y. And we have equal to negative 4 minus 12, which will be negative 16. And for 2y equal to negative 16, we have upon division by 2, the value of y is going to be at negative 8. Okay, so we have half the solution already. And taking what we have now, okay, we have with negative 8, I can plug back into either equation and solving for x. So I'll just take this value into the first. So we have 4x plus 5 times negative 8 is equal to negative 4. So we have 4x minus 40 is equal to negative 4. And if I add 40 to both ends, so you have 4x is equal to 36. And we have with division by 4, x comes out to a positive 9. Okay, so we have x is going to be at 9. You have y to be at negative 8, and checking out, and the result is correct. In the case of what we have for number 4, okay, so we have a system of equations whereupon we have 2x minus 3y is equal to 13, and we have 5x plus 7y is equal to negative 11. And what I have here, now I don't have identical terms in x or y, but what we can do is that we can take multiples of the first and second equations, okay, where we can cancel out one set of terms and solve for the other. And we'll look at it, we'll solve for y, and so we'll just devise a way to cancel out what we have for x. Okay, so think of it like least common multiple of both 2x and 5x would be 10x. So if I make one term at 10x and the other at negative 10x, so I'll do here, I'll make 2x into a 10x and 5x as a negative 10x. So I'll just multiply the first equation by 5 and the second equation by negative 2. And so we're going to have in the rewrite, so if I multiply the first equation by 5, we have 10x minus 15y, and 13 times 5 is going to be 65. And multiplying the second equation by negative 2, I have negative 10x, and what's going to be minus 14y. And negative 11 times negative 2, that's going to be a positive 22. And if we look at adding the equations together, okay, so you have x terms will go out. Negative 15y plus negative 14y will be a negative 29y. 65 plus 22 is going to be at 87. And now negative 29 will go into 87, negative 3 times. So we had that y is equal to negative 3. Okay, so, and I can take negative 3 for y into any of these equations, whether it's in the raised form or any of the original forms. And we'll say we have 5x plus 7y is equal to negative 11. So we'll just go with this version of the equation. So we have with 5x plus 7y equal to negative 11. So you have 5x plus 7 times negative 3. And we have is equal to negative 11. And here we have 5x minus 21 is equal to negative 11. And if I add 21 to both sides, we have that 5x is equal to negative 11 plus 21, which will be a positive 10. And with division by 5, we had that x is equal to 2. All right, so we have for the system, we had that x is equal to 2 and y is equal to minus 3. And we have upon checking out, and the result is correct. In the case of what we have for number 5, okay, we're looking at classifying what we have in the systems, okay, and we're identifying as inconsistent, consistent dependent, or consistent independent. Now for what we have with the first system, Okay, we have these two lines, they intersect at one point. So we have one solution, and any system that has a finite number of solutions is going to be consistent and independent. And this means that the system has, okay, first of all, we have a unique solution since we have one point of intersection. So here we have at this point, we have x at 2, y at 3. So we have x at 2, we have y at 3. Now for what we have in the case of system B, okay, now we have both lines running parallel, meaning that there is no meeting point and thus no solution. So if there's no solution, that means, and the lines are parallel, we have an inconsistent system. Again, we have no solution. And if line 1 and line 2 turn out to be identical, that means you have all values shared in common. And this is a situation where if you have an infinite number of solutions, that is where the graphs become the very same line, we have consistent and dependent. Thus we have a consistent dependent system, and we have infinitely many solutions. And we have upon checking out, and the result is correct. Okay, for number 6, you have two systems of equations that are given. And it says that for each of them, choose the best description of the solution, and where applicable, give the solution. Now we have, in the case of number 6, okay, we have negative x minus 2y is equal to negative 8. And we have x plus 2y is equal to 8. And if I look at trying to find a solution, and we have for this system, let's say that if I add these equations together, what's going to happen here is that we're going to have, in this particular layout, negative x plus x is 0, negative 2y plus 2y is 0, negative 8 plus 8 is equal to 0. So this would be a consistent dependent system, and this would have infinitely many solutions. Now, in terms of what we have here, if we're looking at finding out what we have for y that will satisfy the whole system, in other words, there has to be a consistent relation between x and y. So for what we have here, okay, say if I can take either equation and express y in terms of x. So we can say we have x plus 2y is equal to 8. And if I isolate the y term, so we can say that 2y, and upon taking x away from both sides, I have 2y is equal to negative x plus 8. And we have with division by 2, we have that y is equal to negative x plus 8 all over 2. Okay. And so we have here for this particular system, again, you have infinitely many solutions where we have y is equal to negative x plus 8 all over 2. And in this one case, you have infinitely many solutions. And for y itself, we can type in negative x plus 8 all over 2. Now, in the case of the other system, we have x plus 2y is equal to 2, and negative x minus 2y is equal to 2. And if I look at adding these equations together, so we have x plus negative x is 0, 2y plus negative 2y is 0. However, 2 plus 2 is equal to 4. And 0 plus 0 is 0, and that is not equal to 4. So in this case, there is no solution for x or y. And so the system has no solution. And testing out what we have for both of these items, and the result is correct.